As you know that we have been sharing application related to different industries, and as a user you can always connect how this will add value to your laboratory and your work. Okay, as Ranjani mentioned, and today I'll be sharing some of the application related to forensics science, and let us see how this Py-GCMS can really add value to a forensics chemistry lab. I'm going to spend a minute just to introduce Frontier Laboratories. Frontier Laboratories is a Japanese organization and market leader in analytical pyrolysis technology. We have two major products, like one is the analytical pyrolysis system, the multifunctional pyrolyzer, that is mainly and majorly used for the chemical analysis of polymeric materials. And the second one is the tandem reactor, and that is widely used for catalyst screening and catalytic pyrolysis and co-pyrolysis. We also have some unique accessories like a magic chemsorber, which is something similar to SPME, and also we have this unique ultra-alloy metal capillary column. So you are always welcome to visit our website, the www.frontier-lab.com, to know more about our products and applications. Okay, first I have to tell you honestly that I'm not a forensic scientist. So the way that I talk today will be more on the workflow or the technique aspect of this pyrolysis GCMS. Okay, but I will also try to give a brief introduction about forensic science and forensics chemistry, and also then share about some of the application what we know. But as a forensic scientist or chemist, you can always like think or exploit how this technique can add value to your laboratory. Okay, forensic science is actually a use of the scientific methods or expertise to investigate crime or examine evidence that might be presented in a court of law. Okay, the term forensic science refers to a group of scientific disciplines which are concerned with the application of their scientific area of expertise. As you all know, the forensic science comprises a diverse array of disciplines from fingerprint, DNA analysis to anthropology and wildlife forensics. Within forensic science division, you may like see different departments dealing with different objectives. Okay, so we have tried to list down the different departments that one will find within a forensic science. Okay, biology, serology, chemistry, toxicology, and so on and so forth. So what I basically want to highlight from this slide, because in each division or department, you may find the use of the chemical analysis, even though the chemistry department will be dealing with chemistry or chemical analysis widely, but even in other departments, you may see the value of chemical analysis to really answer some of the analytical challenges that they may be facing. So in forensics investigation, the forensic scientist or the investigator is always look for some physical evidence that can be imprints, broken glass, hairs, fibers, and so on and so forth. And as you can see from this list, some of this specimen or the evidence can actually go through or undergo some chemical analysis to really find some or determine some evidence that can be supported by the scientific interpretation also. So this is what you will be learning from today's presentation. So within forensic science, as I said, the forensic chemistry department is the one that is actually dealing with most of the chemical analysis. So forensic chemistry is actually specialized subfield of forensic science involving the application of techniques and principle of chemistry to the field of forensic investigation. And you see, as you know, many times it involves complex procedures of chemical analysis, okay, that is used to identify the elements and compounds of the different physical evidence. Okay, and it's important to use these identification procedures that are highly reliable, because the interpretation what we make out of these testing procedures are critical, and the many of the decisions are made based on this analysis. So it's important to choose the right technique and right procedure for such analysis. So in forensic chemistry, okay, mostly they deal with analysis of biological or non-biological materials, okay, found at the crime scene, and they try to determine the chemical nature and composition of the materials. And these findings or reports will be like created as the official report that can be presented in the court. And as a chemist, you may have to like even testify about these findings in a court of law, as and when it required. So as a chemist, it is not just doing the analysis, you may also have to use your expertise to testify the findings in a court of law or in within the forensic chemistry lab, that you will find many of the analytical techniques employed, starting from the UV visible spectrophotometer, mass spectrometry, and GC and HLC, even the trace elements techniques like AAS, ICP, ICP-MS, also the other molecular spectroscopy like NMR, in some cases even the neutron activation analysis. Okay, in today's talk, you will be like learning about the GC related applications. As I was showing this list of physical evidence, you can see from this slide again, so many of this physical evidence can undergo a chemical analysis, and in some cases when they are interested in looking at the organic compounds of such evidences, then GC or GCMS is mostly used, and this is what I'll be sharing today. Okay, so it can be any kind of evidence which can undergo a direct analysis or sometime through a chemical sample preparation followed by the analysis. And pyrolysis GCMS, what we will highlight is how this specimen can be analyzed directly without any sample preparation. Okay, just for the benefit of some of the audience who may be new to this pyrolysis, I just want to give a brief introduction. Okay, pyrolysis GCMS is a hyphenated technique where the pyrolyzer is used for sample introduction. Okay, then after the heat treatment or the thermal treatment of the sample, the compounds evolved or break down from the macromolecule will be sent to the GC column for separation. Then subsequently it will be detected by the suitable detector like MS or even some cases FID or other detectors. The key advantage of this pyrolysis GCMS, it allows a direct sample analysis without any sample preparation. That means you can take any solid sample directly introduced to the microfurnace, then you do the thermal treatment, then the compounds of the material can be easily characterized. The second benefit of this hyphenated technique, it can operate at high temperature. As you all know, the GC inlet temperature can go only up to 300, and some of this polymeric material, okay, that may require high temperature. Even for some thermal desorption studies, you may have to go beyond 300. So such techniques can be easily employed using this hyphenated technique, this pyrolysis GCMS. Okay, so just to understand about pyrolyzer or the pyrolysis GCMS, you can assume that the micropyrolyzer is nothing but a sample introduction system that is coupled to a GCMS for direct sample analysis. Okay, let me briefly explain how this pyrolysis is helping to analyze macromolecules. As you all know, when you do a combustion, okay, any organic matter, here the first example that I'm sharing is butane. So butane is more like a small molecule. If you burn it in air, then it goes to complete mineralization. On the other hand, if you do such heat treatment in an inert atmosphere like under helium, then you get to see the butane break down into smaller molecule, okay, like methane or ethylene or even like propylene or even acetylene also. So when you are doing such thermal treatment under inert atmosphere, from this product distribution, you can always trace back the type of material that you are analyzing. Okay, this is exactly what is happening in GCMS analysis. But as I said, the temperature can go only up to 300 in the inlet. So if you have sample like polymer, okay, for example, the polyethylene, and that is a macromolecule. So the 300-degree heating is not sufficient, is one of the limitation. And secondly, when you drop such a kind of solid sample into the inlet, then you are easily contaminating the inlet and ion source. So that's why you need a kind of external device to handle such type of samples. Okay, this micropyrolyzer allows you to treat the polymeric material like polyethylene at high temperature. So again, it's happening in inert atmosphere. So you are able to see the product distribution of the different hydrocarbon, from which you can identify the primary or the parent material. Every polymer has got a unique fingerprint or pattern. So here I'm just showing some of the examples of this polyethylene, polypropylene, polystyrene, and also this methacrylate copolymer. So this fingerprint can be used to identify these polymers when it is treated as a unknown sample, or even when it comes as a mixture of like different polymers. So this is the unique feature of this pyrolysis GCMS. So this pyrolysis GCMS can have like can be used in different ways, or we call it different analytical techniques. Okay, so the first one and most the important one is the evolved gas analysis, which is something similar to TGA. Later I will explain what exactly it means. Then the second technique is called single shot analysis, where you are uh, doing a flash pyrolysis of the material, and that allows you to look at the product distribution of additives and polymer in one stretch or one go. The double shot analysis allow you to do a two-segment analysis, okay, whereby the first step you will be looking at the additives present in the sample. Then the same sample you treat it at high temperature, that allows you to look at the the polymers present in the sample. To further exploit this technique, you also have this EGA hard cut. Okay, that means within one sample you can have segmented thermal cutting. Okay, so we call it hard cut. It's almost like a two-dimensional analysis. So where the first cut is done by these thermal zones of the sample, then the second separation is done by independent GCMS analysis. So from one sample you can go like get up to 3 to 4 data set just by treating the sample in different temperature zones. So evolved gas analysis is something similar to the TGA, thermogrammetric analysis. So thermogrammetric analysis something is very common and widely used in material characterization. It provides the weight loss information from which you can look at the temperature profile of the material. So in EGA, MS also is something similar, but in TGA, you are constantly looking at the remaining sample mass. But in evolved gas analysis, you are not looking what is remained, you are constantly looking what is evolved. So you are continuously monitoring the compounds that are released while applying a thermal treatment. Okay, so the output what we get from the EGMS is called this EGA thermogram, which is almost similar to the TGA. So the two peak top temperature will tell the chemical nature of the additives and polymer present in the material. In addition, when you click on this peak, you will get a lot of information from the mass spectrum that can also help you to identify the candidate material of this material that is being tested. So in TGA, you don't get that information, whereas in EGA, you are getting this information additionally, because the signal is coming from this mass spectrometry. So the mass spectrum can provide some kind of chemical printing of the different uh, chemicals or even the polymeric material. So that is the advantage I would say that you can get from the EGA versus the TGA. The single shot analysis, as I said, it's called flash pyrolysis. You treat the sample at one temperature and it evolves the additives. Also, it breaks down the polymeric material. Then you get all these compounds like being separated through the GC column, and you have one chromatogram that is called pyrogram. In some application, you may find it some difficulties because of the co-elution or sometimes the merging of different peaks or even the sensitivity difference for different compounds. So in such scenario, it is recommended to go for the double shot analysis, where you can do a kind of to a segmented analysis. Initially, you carry out the thermal desorption for looking at the evolved gas or the compounds released from the material. Then the same material, you take it to the high temperature for complete decomposition, and you will see the nature of the polymer present in that material. So this is generally recommended for more clean and precise chemical analysis. But in some application, if your interest is only on the polymer, you can always consider the single shot analysis also. Okay, the fourth one is something is mainly for contamination analysis or detail analysis. As I said, one sample when you apply this thermal treatment starting from 40 degree to 500 degree, you can segment them into different zones, we call it. Okay, 40 degree to 120, 120 to 220, 220 to 310, and 310 to 400, and 400 to 500. So you can get five different chromatogram or the pyrogram, okay, from one single sample. So that means you are getting more cleaner and cleaner chromatogram that allows you to do the sample, the data interpretation more easily. This is highly recommended for some contamination analysis or failure analysis, and particularly even in forensic analysis. Okay, so what I have done so far, I have briefly introduced what is the forensic science and forensic chemistry lab, and what are the different analytical techniques employed. Then we have done some additional kind of insight to the GC, and where we have emphasized on the use of this pyrolysis GCMS. And I have also briefly talked about the four different analytical techniques that one can employ within this pyrolysis GCMS. From now on, I'm going to share some of the application that are related to forensics science. Okay, I have categorized into four different groups. The first one and the major one, I would say it's polymer and additive analysis for forensic purpose. Then I will share some of this drug analysis for narcotics, then also the food forensics and also the environmental forensics. As I said, I'm not a forensic scientist, so as a forensic professional, you have to see how this technique can really add value to your laboratory analysis. And if you have any specific question on any specific application, you are welcome to really interact with us. Then we can share the instrument features, and that can really assist you in solving some of the analytical problem in your laboratory. Okay, under this polymer and additives analysis, the most common one in forensic is actually the tire and also this automobile paints. Okay, as you know, the tire actually is made out of like it's a compound rubber, which will have natural rubber and also the synthetic rubber, and there are different additives they are added to really influence the characteristic of this tire. Okay, so when you are trying to characterize a tire material, it is important to understand what are the different type of polymer present, whether it is a synthetic one or the natural one. Also the different additives like vulcanizer or the anti-aging agents and so on and so forth. So these chemical informations are critical if you are trying to differentiate a tire from a different industry or from different car. Okay, here is a kind of example of the output of a pyrolysis of the tire sample. So the Py-GCMS can provide you the pyrogram that will tell what kind of polymer present and what kind of additives present in your tire sample. Within tire, you also may know that the different part of the tire, like thread, shoulder, sidewall, and bead, they all use a different material. So finally, the output or the product, what you say, is actually consists of different polymer that are put together to have this final product of tire. So it is important to see how the chemical distribution of the different parts. So this information can be used for interpreting the sample that is found from a forensic evidence or a crime investigation. I'm going to share one publication that has been reported on this analysis of tire and tire traces, okay, using FTIR and Pyrolysis-GCMS. Because as you know, FTIR also widely used for this kind of analysis, but it has got its own limitation. So that is beyond the scope of today's talk. But if you have any question on comparison of FTIR and Pyrolysis-GCMS, you are always welcome to contact us. So we will share the knowledge that we have on this. Okay. So as you know, vehicles are commonly used in the commission of crimes. Okay, quite often it is the only link between the crime and criminal. So one way this link is formed through, like, you can have some kind of traces of sample from the road dust, and that can help you to look at the tires of the vehicle. Okay, that can really help you to solve some of the physical evidence investigation. In this report, they have taken 59 tire samples, okay, collected from car involved accidents. Okay, out of this, 58 samples are actually like coming from the summer tires and one sample coming from the winter tires. Okay, these samples were collected in France. All these 59 samples were analyzed by FTIR with the ATR and drifts. Also, all samples have been processed with the Py-GCMS as well. Excuse me. So the findings of this study shows that the pyrolysis GCMS showed a promise in the analysis of both reproducibility and discrimination. So this is what our objective. When you are trying to do a kind of forensic analysis, it is important to get a data that can be used for differentiating one product from other product. Okay. So the Py-GCMS data has been treated with the principal component analysis and LDA that provide a kind of a cluster information that can be used for differentiating the tire products coming from different cars and different brands of tires. So this data set can be used for a kind of unknown samples that is coming from any forensic investigation. So this is one of the application where you see the use of pyrolysis GCMS for forensics application. So another one, because whenever we talk about the road accidents or any kind of incidents, crime incidents, so in addition to tire, people are always looking for this automotive paint samples. Okay, this is another kind of specimen, and which was even like shared in my list of physical evidence. So again, this application or this publication shows the analysis of 100 automobile paints that was analyzed by this pyrolysis GCMS, and particularly they have chosen 5 different color paints. And what they have done is, based on the Py-GCMS data, they try to do a pattern recognition for forensic discrimination. Okay, so for pattern recognition, they have employed two different type of data analysis tool. One is this principal component analysis. The other one is the canonical variance analysis. Okay, in this slide, what you see, the white paint, okay, coming from two different car, okay, of two different years of the model. You can see, even though they are white paints, the pyrogram of these two samples are different. Okay, so that means the chemical composition of these two white paints are different. So it is important to have this database to really deal with unknown sample that is collected from any forensic crime or the investigation. So as I said, this bunch or the large data set has to be treated with the kind of data variation analytical tool. So here the first one is from this canonical, so where we are able to cluster the different color paints, okay, based on its chemical composition, and that can be used for dealing with unknown sample analysis. So other data set is basically treated with this principal component analysis. Okay, so here they have taken the data set of like 60 samples, and they were able to differentiate the different color of these automobile paints, and this is what exactly you need when you are collecting any kind of trace of this paint chips from the crime investigation area. Okay, so this is like second example where I showed the Py-GCMS can be used for analyzing the automobile paint chips from the crime investigation area, or if you have any evidence, physical evidence that has got some paint materials. Okay, the third one again, it's also related to the polymer. So it's actually a condom evidence. Okay, again, how one can characterize the condoms of different brands and how this data set can be used for discrimination or differentiation purpose. Okay, so this is again done based on this pyrolysis GCMS profile. Okay, in this particular work, okay, they have taken 70 plus condom samples, okay, and that has been analyzed by the Py-GCMS data. So one, like you can again emphasize on the benefit of direct sample analysis. All these three cases where it is a tire sample or the paint chips or even the condom, the sample can be directly analyzed with the pyrolysis GCMS without any sample preparation. So that means it really helped a lot to reduce your analysis time of different samples. Okay, the pyrolysis data, the pyrolyzates data were extracted and evaluated during this multivariate techniques. Yeah, this is one of the critical requirement when you are using such kind of tool for unknown analysis. Then you need to have a large data set or data set that can be used for doing this statistical analysis through different multivariate techniques, because otherwise it will be a lot of work to really interpret the data. So when you develop such a data set, in these days the solution providers are providing such a database with a library that can be used for your data interpretation. Okay, here as a research work, so they have done this, and they have treated this data on their own through a different statistical tool, and the results actually help them to discriminate or differentiate these samples based on the four main oligomers that were found in different quantum samples, and also the six minor compounds from the siloxane degradation. Okay, here this is again showing the pyrogram of different quantum samples and also the lubricants. Okay, so in some cases what they found that the differentiation based on lubricant is much easier than the quantum sample, because the quantum mostly it will have same type of polymeric material, but the lubricants that are employed within the quantum really allow them to do the differentiation. Okay, so here again the clustering of this data set with this multivariate statistical analysis allows you to see what are the different type of materials. So here they are like marked by different color code, like condoms are with the blue one, and the red one are lubricant, the other one is the physical the hygiene products. Okay, so Py-GCMS can really help you to tackle the analytical challenges of such samples without any sample preparation. At the same time, for data interpretation, it is important to have this kind of large set of sample data pool, so that your data interpretation become easier. Okay, the fourth application on this polymeric material is the classification of 21 fibers or the textile fibers, because as you know, again in crime incident, so sometimes you may find evidence of textile fibers, and from this what can we get is what basically the forensic scientists will be looking, and here analyzing this fiber can help you to really get some kind of navigation or guidance to address the issue. Okay, so two things again I have to repeatedly emphasize. One is no sample preparation is required when you do this kind of samples with pyrolysis GCMS, and the second thing is you don't need a big sample. Also the sample size, the sample mass, mostly you need only 1 to 2 milligram. So even if you have a textile cloth or the fiber from the crime site, so you don't need to use up the entire sample. A small portion of the sample can be used for pyrolysis GCMS, but it can provide you a lot of information. So that is another advantage of this pyrolysis GCMS. So two things I have to repeatedly emphasize. One is the direct sample analysis. The second is the smaller sample size. Okay, it can handle like even less than 1 milligram of sample size. So we have some special tool for handling such type of powdered or greasy samples also. Okay, so this application shows the again the use of pyrolysis GCMS for differentiation of different textile fibers. Okay, so here, as you know, within natural fiber you have the wool and silk, and also the plant fiber like cotton and hemp, and within synthetic fibers you will find this regenerated one, semi-synthetic and fully synthetic one. So all these provide unique characteristic pyrogram, which can be used as a fingerprint for differentiation of different textile fibers. Okay, here I'm just showing the thermogram of this evolved gas analysis of different one, wool, silk, and cotton, hemp. Okay, so the left side what you are seeing is a thermogram where you can see the peak shape and the peak top temperature are different for different. So this information can be used for differentiating different fibers. Similarly, from this peak, you can also get the average mass spectrum of the main peak, and you can also see what is the difference between these. So for example, the animal fiber and plant fiber can be differentiated with the average mass spectrum, but within plant fiber or animal fiber, you cannot differentiate because you have similar average mass spectrum, but the peak shape and peak top temperature are different. So this information can be useful for differentiating within one group the different type of fibers like cotton and hemp or wool and silk. Okay, it's same for another set of examples where we talk about this regenerated fiber of polynosic and cubra, and semi-synthetic fiber of acetate and vinylene. Okay, again, yeah, we have to mention here within the group sometimes the differentiation using the average mass spectrum is different, but the thermogram is really helpful to interpret the data for differentiation within one group. So you may have to use the combination of average mass spectrum and thermogram for differentiating different fibers. This is another set of data. Okay, again showing the difference of the thermogram and the average mass spectrum. So using this data, we were able to differentiate, okay, like 21 different fibers. So based on the sign, the circle one is differentiated by this evolved gas MS data, and but for some data the we can differentiate, but the differentiation is not very distinct. So that means you have to bring it to the another type of analysis called pyrolysis GCMS, where you are employing GC for complete separation of the different pyrolyzates. So that will provide more size information that will add value to this differentiation data. So out of the 21 fiber analyzed, only few fiber that we were not able to differentiate, but most of the other fiber we were able to differentiate either with the EGMS data or the Py-GCMS data. Okay, so this was the summary. So with the EGAMS data that we were able to differentiate 95% of the samples out of these 210, whereas with the combination of EGAMS and pyrolysis GCMS, you can even go up to 2,205 samples. Okay, so only few samples that we were not able to differentiate from the pool. So the combination will be useful when you are not able to do by one approach of this evolved gas analysis. Okay, this is another example of differentiating polymeric material. Okay, so far I have shown the application of Py-GCMS for tire traces and automobile paints traces, and thirdly the textile fiber traces. The fourth one is more like in any other like dispute on material differentiation. Okay, again, if it is polymer related, that can be easily done with Pyrolysis-GCMS. Okay, so we can easily use this data with the principal component analysis. Then we can tell what type of polymer from this dispute sample. Okay, like these examples, we have done this differentiation studies for different things. Okay, fabrics, oil-based ball paint. So some of the ink analysis I will be sharing later. Then also the polyolefins, polystyrene, excuse me, and polyamides and polyamides. So if you are interested to know more of this, you can visit our website and download these application notes. Okay, now I move on to the second area of this forensic analysis of drugs. Okay, so as I said, the pyrolysis GCMS can handle the samples directly, and it can also handle a small mass, a small size sample. So when you have some difficult samples, okay, the powders stick on a fiber or paper, or even it is a greasy sample, transfer of this sample to a pyrolyzer will be very difficult. Okay, so we have developed something called the small syringe. Okay, where the syringe tip we have inserted a micro coil. Okay, deactivated micro coil. So this coil is more like a metal brush, you can say, and it has got some affinity for these powders or grease. So when you scratch this microcoil into a sample specimen from a dust or fiber or grease, some of the sample will be trapped into this microcoil, and this coil can be directly inserted into our furnace for thermal desorption or pyrolysis. So that means your sample preparation becomes much easier for such type of samples. Okay, so this is reusable for 5 to 10 analysis, but they are not expensive also, so you can always get this micro coil syringe for this kind of analysis. Okay, so the first example that I'm going to show with this is differentiation of trace amount of drugs stain on a cloth. Okay, that is analyzed using this microcoil sampling device with the gas chromatography and mass spectrometry. So for this demonstration, we have taken one of these medication, okay, that we have opened and spread on a cloth. Okay, then we really dust it, and this fiber later on scratched with our microcoil, and this microcoil is introduced into the pyrolyzer for the analysis. So this sample basically contained all these different chemicals, okay, and in different quantity. And what we can see, all these samples can be identified by this simple analysis. Okay, so this is what basically the objective of this application. So when you are trying to do any drug analysis, okay, and that is something sticky or something that stain on a cloth, okay, on a paper, then you can use this microcoil to take this sample, extract this sample, then analyze directly. Okay, so this just confirmed that the chemical present in the medication can be identified or determined using this approach. Okay, we have also compared how this is comparable to the normal liquid extraction or solvent extraction. So in this case, we have taken a pill, the medication that is soluble in a solvent. So we have compared. So you can see that all these compounds that were identified in liquid injection can be like found in our micro sample collection device as well. As I said, this liquid injection is something is not possible for all type of samples, because many times you don't see them soluble in any of the solvent, or if you are going for some solvent extraction or other extraction approach, you have to do this as a very lengthy sample preparation procedure. So on the other hand, with this micro sample collection device, you can take the sample immediately and analyze immediately. So you are able to provide answer within short period of time. Okay. This is another example for using this microcoil device. Okay, as you know, this cannabis, okay, this is actually uh, has some restrictions in some of the countries, but countries like the US, there are some kind of legal uh, way to law is available to sell this product in as a kind of medication, or even in food also. Okay, but in Asian country it is still restricted. So if somebody want to look at the illegal traffic of this cannabis, okay, and maybe they have already cleared, but if you found some kind of plastic bag where you find some kind of traces of powder, and if you suspect can it be cannabis, then this powder stick onto a plastic bag can be easily collected through this microcoil, then that can be analyzed by the pyrolysis GCMS. If it is really coming from this cannabis source, then you will see a strong peak for this THC, okay, the delta THC. So this is another example of this drug or the illegal traffic of these drug samples that can be analyzed by pyrolysis GCMS using this microcoil sample device. This is another third example, I would say. The propolis is again used as a medication, but again, they are planted in different locations and they have different chemical properties. So when it comes to any kind of dispute on this product certification, and Py-GCMS can be used for analyzing this crude drug propolis. So where we can show the differentiation, okay, the aromatics and phenol compounds do not show big difference, but the ethyl esters and flavonoids, there are good kind of difference between the sample. So this is how this technique can be used for solving the dispute of such crude propolis from any kind of civil dispute. Okay. Okay, now I'm moving on with another set of application where we talk about the analysis of ballpoint inks. Okay, this is also another kind of evidence that the forensic scientists may be looking for when it comes to any kind of documentation, or even for some kind of currencies dispute. Okay, so as you know, okay, again, this has got a lot of organic compounds within the ink, and that can be easily analyzed by a GCMS. So here again we are showing the benefit of direct analysis of these samples with the pyrolysis GCMS. Okay, as you know, there are different type of ballpoint pens available, which is like using oil-based inks, sometimes the water-soluble inks, and some use this gel ballpoint inks. So they all have different characteristic, and they have different chemicals also. Some uses dyes, some uses pigments, some uses additives, and so on and so forth. Okay, and their viscosity is different, and the writing characteristics or features are different. Okay, so when you have any kind of dispute on this ball pen, so if you find any of the traces of paper and you want to know what kind of ink is used, and you can use pyrolysis GCMS for such analysis. Okay, so to demonstrate that, so we have taken a different type of inks. Okay, and these inks were analyze directly, and also we have scribbled the paper with these inks, and we have collected those specimen of this ink dots on the paper, and these papers were directly analyzed also. So when you extract or the ink sample with the different kind of solvent, okay, and they usually have some precipitate, some will form a film, and they also have some non-soluble fraction in water. So all carries different chemical. So one way you can analyze the entire ink in one stretch, or if you want to show the differentiation, you can also use the different extraction method from this raw ink. But when it comes to the paper, uh, you don't need any sample preparation or extraction. This paper can be directly introduced into the furnace, and you can do this evolved gas analysis, okay, by treating the sample from the 200 degree to 500 degree. Also, you can get the pyrolysis GCMS of a hot cut of a specific temperature zone also. So this information can be put together to look at what kind of ink that was found in this dispute sample. Okay, so Frontier Lab has got this library that is having around like 600 additives data set that can that includes a lot of these inks also. So when you have any kind of unknown ink traces on a paper, that can be easily analyzed with the Py-GCMS, and our library will help you to identify the type of ink found in that kind of samples. Okay, so now I move on to the next application, that is on food forensic. Okay, in food forensic, generally the dispute many times comes on the food adulteration, because they always try to blend the low value product with the high value product to maximize their profit gain or the business gain. But as a user, sometimes you end up using buying wrong product at higher price, and there are always cases in this when they are doing it on large scale. So here we are showing one application where how the rapid differentiation of vegetable oils can be done with this reactive pyrolysis. Because as you know, oils generally they have this fatty acid profile, and fatty acids can be generally they are analyzed by this FAME, right? The fatty acid methyl ester. So the same can be done with our pyrolysis setup also. And when you use the pyrolysis setup, you don't need to provide a separate reaction time. It is happening in situ. So you take sample and this uh, the reagent together, and while heating the sample, this reaction is instantaneous, and you are able to see the methyl esters of these fatty acids. Okay, using this technique, we have demonstrated the differentiation of different oil, this rapeseed oil, soybean oil, olive oil, and also the sesame, and particularly when it comes to the blend of this, how we can differentiate with the Py-GCMS data. Okay, so as I said, when you are doing vegetable oils, you have to go through this esterification. Okay, and traditionally or conventionally people use methanol with the KOH, okay, and with the sulfonication. But when you use pyrolysis GCMS, you can do it in situ. So you take sample and the reagent together. So instead of methanol, we recommend TMAH for many of the reactive pyrolysis analysis. But for this particular application, we recommend a trifluoromethylphenyl trimethyl ammonium hydroxide. The reason is when you do with TMAH, it leads to more isomerization of these polyunsaturated fatty acids. Whereas if you use the TFPTAH, the derivation is the isomerization is minimized. So that means your data analysis become much easier compared to more isomers. Okay, that's why for this particular analysis, we recommend to use the trifluoromethylphenyl trimethyl ammonium hydroxide. Okay, so that means you take sample and this reagent together, and you drop them into the micro furnace, and what you get this reactive pyrolysis data is the pyrogram. So you can see the distinct data obtained for different type of oils. Okay, rapeseed oil and rapeseed soybean olive oil. So what you basically see, the difference in this number of carbons and number of unsaturated carbons. Okay, and this ratio can be used to differentiate the different products. You can see the difference in this unsaturated carbon for the rapeseed oil between for the 16, versus 0 for rapeseed, soya bean, olive, and sesame. Okay, and when you do a blend sample, you can figure out what it could be. So this blend can be mentioned. It may be a rapeseed oil containing or major portion of rapeseed oil. Similarly, this ratio can be used to differentiate the vegetable oils of unknown nature. Okay, so here we have done the pure oil, the standard, also the extracted blend, and you can see that they are in very good agreement. Okay, that means this technique or this approach can be used for differentiation of the oils. Okay, again, you don't have to have the oil sample if you have the kind of incident where you have oil spill on the ground. You can just use a oven cloth to wipe it off. Then this cloth portion of this cloth can be easily analyzed, or you can use our micro uh, coil sample collection device for taking traces of this oil from the situation. Okay, then that can be analyzed directly. Okay, this is another application on this beeswax. Okay, beeswax, as you know, it is widely used in medical and cosmetic. Okay, and again, for economic benefit, they try to blend this with illegal beeswax, is called the petroleum wax. So it may pose some health concerns when they use this wrong product for different cosmetic or medical purposes. So it is required to differentiate this product when there are some dispute on this kind of illegal product selling or product usage. So we can analyze this beeswax, okay, coming from two different sources, and we also have analyzed the petroleum wax. So what you can see, when you find the petroleum wax, okay, peaks, the straight chain hydrocarbons may be found in beeswax as well as the petroleum. So if you are characterizing using only these short chain straight chain hydrocarbons, then you won't be able to differentiate, because even the people bring petroleum wax mixed with beeswax for product gain, you may not be able to identify or determine this difference. But when you see the other data like palmitic acid esters of high alcohols, then this is something you don't find them in petroleum wax. So this is how you can see the product differentiation and also the blend of petroleum wax from the beeswax. Okay, so this is another simple application where we can show the benefit of pyrolysis GCMS for uh, product differentiation from any kind of dispute sample. Okay, now I move on to the next application where it also can be considered as part of the food forensics. Okay, again, it will fall under this food adulteration. Okay, and people are trying to get product a profit gain by using low value product into the high value market. Okay, so again, some of these chemical characteristic can be done with our pyrolysis GCMS, but we have another device is called actually the chemisorber. Okay, this is nothing but a small tube, a ceramic tube that is functionalized with two kind of polar, like it's called polyethylene glycol, also the PDMS that is meant for non-polar compounds extraction. So this can be used for headspace, or you can immerse, you can also collect through air pump also. This device is something, is a offline sample collection that can be used for different samples. Okay, so and it can be used for headspace, and also you can insert or immerse into the liquid. You can also collect any kind of air samples from any kind of affected area or indoor or outdoor air quality investigation. I'm showing the use of this device for product differentiation of this wine. Okay, again, yeah, wine comes with the different labeling and different product characteristic. So if you use our chemisorber and with the thermal desorption GCMS, then you can easily differentiate. mostly people will use only one type of chemisorber, but we have this complement of the two type of functionalization, so that will help you to get all the compounds that are important for such product differentiation. So in general, if you are looking for this kind of volatile compounds, the polar polyethylene record device is more useful, but it's always recommended to collect data with both of this device. Okay. So this is another example of the cheese. Again, as I said, there are cheese coming from different continent, different origin, and their prices are different. So as part of this adulteration or authenticity, you need to have such a chemical fingerprint, and that can be done with our system, Pyrolysis GCMS, and this chemisolver. Okay, so that can really solve or address the dispute of such product adulteration issues. Okay, the last application that I want to highlight is the environmental forensics. Again, these days people are talking about different emerging contaminants that are personal care products and pharma and personal care products. Similarly, some of these endocrine disrupting chemicals. So these samples, okay, or these compounds, when people are trying to collect, analyze from a different compartment like wastewater or landfill or sediment or biota. So the sample preparation become a tedious one. Again, we can employ our magic chemisorber for extracting these compounds from different environmental samples, then subsequently analyzed by this thermal resorption GCMS using our pyrolysis GCMS setup. Okay, another application here we are showing, because phthalates, as you know, they are restricted, okay, in plastic bottles. So here, as a part of this environmental forensic investigation, the phthalate sample, like phthalates from the bottled water, has been analyzed using a hollow fiber solid phase. So it is something similar to our microcoil. So where we have attached a hollow fiber and use it to extract these phthalates from drinking water in a water bottle. Then later on you go through the thermal desorption. So this can be analyzed. So this is what basically I wanted to highlight. Even though the pyrolysis GCMS is meant for this high temperature analysis, but it can also offer other applications for thermal desorption, okay, where you can use a different type of sampling devices, okay, what we have developed and what is developed by other groups also. Okay, as you know, the microplastic is another emerging contaminant. So we have a special setup, okay, with the because microplastics are nothing but polymers. So since we have vast years of experience in polymer analysis, so this microplastic can be easily handled by our technique and our system. So here, the identification of debris, okay, uh, collected from ocean. Okay, so just by analyzing these debris, you can see what kind of plastics they belong to. So here we have shown the difference of the pyrogram or the pattern of uh, three different microplastics: the polystyrene, polyethylene, and polypropylene. Okay, so with that, I would like to wrap up this presentation. So as you would have seen from this 30-45 minutes talks, pyrolysis GCMS is a powerful tool which is suitable for direct analysis of micro amounts of sample. Okay. At the same time, this pyrolyzer allows you to treat the sample at very high temperature, which are required for some of this macromolecule analysis. Okay. Analysis of polymers and additives are its key application, but it can also complement other type of volatile organic compound analysis through this thermal desorption GCMS approach together with SPME or SPE. So we have shared few applications to demonstrate how it can be employed in forensic analysis. So as I said, as a forensic chemist, you can always exploit this technique to solve many of the analytical challenges that you may be facing in forensic analysis applications. So with that, I would like to thank you all for your kind attention. If there are any questions, yeah, I will try to see the chat box, then I can try to answer them. Yeah, if you are not posted your question, please consider posting your question in the chat box. We can address it one by one.